When getting the MAC address, we needed to decide what was local and what was remote. So what we looked at was the network portion of the IP address to make that determination. We found that by comparing the IP address with the subnet mask to locate the network portion of the IP address. The network portion, or the subnet, is really what we need to take a look at next to see how we determine whether something's local or remote. So subnetting is that process of finding out what's local or remote for me. So when we look at an IP address, for an example, 192.168.1.100, and we have a subnet mask of /24. Again, slash notation is one way that we can write it. We can also write our subnet mask in the dotted decimal form of 3 or 4 octets, 255.255.255.0. So 3 octets of network, 1 octet of host. So how do we determine what's network and host, and how does this /24 relate to these 3 255s? So maybe a quick discussion of what slash notation is. Slash notation is the number of ones in your subnet mask. If I were to convert 255 in decimal to binary, that comes out to 11111111. And again, if I convert 255 to binary, it's 11111111. If I convert 255 to binary, it's 11111111. And if I convert 0 to binary, it's 00000000. So, as I had mentioned before, when we look at an address, it's just 32 bits. It's not 4 groups of 8. We put them in 4 groups of 8 for our consumption, so it's easier for us to see. The computer, the router, the switch, the printer, the IoT device, the camera, the thermostat, whatever you have that's communicating, just strictly looks at all 32 bits. The subnet mask is what we use to identify the interesting portion of an IP address. So wherever there are ones in a subnet mask is important to us. So we determined that we were going to have an easier, what's an easier way to format this? Well, why don't I just tell you how many ones there are in the subnet mask? So there's 8 here, plus 8 more here, plus 8 more here, so that equals 24. That's my slash notation. So a much easier notation to put it in is in that slash notation. So that's what we tend to do. And again, what it identifies is the interesting portion of my IP address. If I were to put my 192.168.1.100 over the subnet mask, 192.168.1.100, the process that we use, it's called the logical ANDing, and we don't need to go through that here, as long as you understand that whatever this 192 is in binary, if I logically AND it with all ones, it comes through. So whatever 192 was before, if it's all ones, 192 is after. 168 drops through. 1 drops through. The zeros block everything. So if you're logically ANDing with a 0, it will always be 0. So this 100 can't come through, so my last number is 0. This is the network ID. It's just looking at the network portion. When my computer is trying to determine what MAC address it needs to ARP for, what it's looking for, it compares the destination address with its own address. So if I put my PC back down here, just to put a little graphic in, connect it into a switch, connect it into a router that's going somewhere. Again, I don't know where it's going, so we'll just call this a cloud someplace. My PC is 192.168.1.100 /24. That means I'm on the 192.168.1.0 network. What addresses did I give my router? 192.168.1.1. Again, very common for us to give the first address in a range to our default router interface, our default gateway. So my PC will actually know the default gateway is 1.1. So what my PC looks at the network portion to compare. If I'm trying to talk to another PC on the same network as me, so here's PC number 2. This guy's going to be 192.168.1. What? I don't care, 5. Doesn't matter. What network is, when I compare it with my subnet mask, 255, 255, 255.0, the 192.168.1 pops out. This is the network. I'm trying to talk to 192.168.1. I'm on 192.168.1. Hey PC, give me your Mac. Now, I'm trying to talk to some other entity, some other device in my company. So in my company, I've got this other server that sits over here. It's just a file server. This guy is sitting at 192.168.31.65. That's who my PC is trying to talk to. I need to look at the network portion. So my PC is trying to talk to 192.168.31.65. So I use my mask. And what pops out? 192.168.31. In the zeros out here. So now my PC goes, I'm on the 192.168.1 network. I'm trying to talk to 192.168.31. Hey, that's not the same network. So what does my PC do? Hey router, give me your MAC. And it puts the router's MAC address. The destination IP is going to be 31.65. This is the destination IP. This is the destination packet address. The destination frame address is going to be the router's MAC address. So it'll be the router's Ethernet MAC as the destination frame. It's all based on this concept of looking at the network portion of the IP address. Again, that's the subnetting piece, is by taking a major network boundary that someone gave me and then making it smaller if I need to do that. So again, subnetting. Let's try that again, shall we? Subnetting is the process of taking what we have and making it smaller. And what we really, making it smaller, taking the network portion and making it a finer granularity so I can have more devices in my network. If I can do that /24, so if I had a smaller number on the left, like a class A address, 24.1.2.5, there's an address. What's the network portion? You can't tell me what the network portion is. Why? Because I didn't give you a mask. But I like /24. That means my network is 24.1.2.0. Oh, did I say 24? /24, 24.1.2.5/16 instead. That means my subnet is 24.1.0.0. 16 is 16 ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then I'll have 16 zeros. So what's my dotted decimal mask? 255.255.0.0, which means I'm only looking at the first two octets. The first two octets, 24.1. Hey, 24.1. Got to zero out the rest because that's what my subnet mask does. So this is subnetting on an octet boundary. And again, today in most organizations, that's what we do. Again, maybe we're not using a real 24, a global address. Maybe internally, we're just using the 10 space. Does it really matter whether I'm 24 or 10? No, it doesn't make any difference at all. 24 actually belongs to somebody. And we typically use what's known as a private IP address internally. So a 10 address. So the 10 space, or 172.16 or 192.168. These are all private IP addresses. Whoops. Private IP addresses. And those addresses are what we use internally. So if I have a 10 address, then I can use whatever I want. 10 is what it starts with. I can use anything, any value I want out here. So why wouldn't I just put my subnet mask right there on that dot boundary so whatever I see makes life easy for me? Because once I put my slash boundary or my dot boundary in the middle of this number somewhere, which I can do, instead of being /24, what if I made myself /28? Again, if I actually do out the binary, and again, I'll show you again more in a second, then the fourth octet actually has this. So up here, if I were to say that this number here, well, I don't really want to do it this way. Let me put the whole thing out. 255.255.240. 1, 2, 3, 4, 5, 6, 7, 8. And on the last octet, it's 1, 2, 3, 4, 5, 6, 7, 8. That means whatever this number is out here, it's split into two halves. If this number was 5, a piece of 5 is host, and a piece of 5 is network. That's not very clear to us. When I look at 5 and you tell me that a piece of it is host and a piece of it is network, what does that mean? Again, it's not overly complicated when you learn the process, but initially it would be so much better if we just subnetted on that octet boundary. So that's what we try to do. And again, internally, if I can use the 10 space, it just makes life better for me to make this 24. And I would say that's probably the most common IP subnet mask that you would see out there, is that /24, because that's what we do today. So why did we not always do this? Well, early on, we didn't have this concept of private IP addressing. So if we look at just the private IP addressing piece, and again, I probably should give you those numbers out here. The private address space was defined by RFC 1918 as being the 10 space completely. So 10.0.0.0 through 10.255.255.255. This was the Class A private address space. We also defined 172.16.0.0 through 172.31.255.255 as the Class B private address space. So again, you can use these if you want to internally as well. And then the Class C IP address space is 192.168.0.0 through 192.168.255.255. These are the private IP address spaces that we work with. Again, most companies today use these internally. There's no reason for you to use public addresses on the inside, and we use the functionality of NAT, and more realistically, it's PAT, it's Port Address Translation, to translate real global addresses into these private addresses that we put internally. And this adds an extra boundary of security, if you will, to my network, because you can't get to any of these addresses from the internet. On your home network, your first PC is 192.168.1.100. From your wireless router at home, you cannot get from the internet to 1.100. It has to be translated. You have to go through the process of NAT, PAT to get from here back in. So the added layer of security is the fact that these addresses don't exist internally, and then you can use them for whatever that you want. It doesn't matter. You can pick and choose. As a matter of fact, you can use any address you want internally. If you wanted to use, I don't know, 200.200.5 internal to your company, you can use that, because your NAT/PAT device is going to actually change this, whatever you use internally, to whatever your real global address is. And your global address was assigned by the ISP. So at home, on your NAT/PAT device at home, your wireless router, your router that you have at your house, you have a real global address on your outside interface, and that was given to you by whoever your internet service provider is. Internally, you can use whatever address space you want. And again, most of the time, most vendors actually use 192.168.1 internally, and so things just work for us. As long as we translate it to that global address on the way out, then we are good to go. So subnetting on that boundary, on my classful boundary, makes life easy for me. Subnetting on the classful boundary, or on the octet boundary, and again, x.y.z.t. This is a dot boundary, an octet boundary. This is an octet boundary. So 16 for this one, /24. Hey Tyler, can you do /8 on this one? Sure, it's a dot boundary, that works perfectly fine. I could use all of these for hosts, but that gives me 8 plus 8 plus 8, that's 24 host bits, 24 zeros in my subnet mask. 2 to the 24th is 16.